right, we get to begin study of exponents with talking about zero and negative exponents. So the first thing I want us to look at is a little bit of a pattern to see if you can see what's going on. So if I start out with a basic thing that you guys would all know, let's say powers of 2, something like that, and I say, let's look at 2 to the third, 2 squared, 2 to the first, 2 to the 0, etc., you can see that I'm just dropping a power every time. When I take 2 to the third, you know that means 2 times 2 times 2, and that equals 8. When I take 2 squared, that's 2 times 2, that equals 4. When I take 2 to the first, that's just 2. What I want you to notice here is that as I drop a power, so I go from 3 to 2 to 1, what's happening here? Okay, I hope you notice that I am dividing by 2 each time. If I continue this pattern, and I go now to 2 to the 0, I've dropped another power, I should again divide by 2. And I'm going to get an answer of 2 to the 0 is 1. Okay? It's not 0, like a lot of you might be tempted to think. It's 1. If I look at 2 to the negative 1, I'm still dropping my exponent by 1. And if I continue this pattern, I should still divide by 2. That means I have at 1 divided by 2, it's 1/2. Okay? Again, continuing that pattern to 2 to the negative 2, I'm going to get 1/4. Okay? What I want you to notice here is that if I take 2 to the negative 2 and 2 to the 2, I have 4 and 1/4. If I take 2 to the negative 1 and 2 to the 1, 1/2 and 2. You can notice that those numbers are reciprocals. Okay? By the way, this will work with other ones too. If you just try on your own looking like at patterns of 5, you can kind of see what you think happens here. Okay? So this is what's going to be 2 rules that we're going to have. Our property is the first one. When you have 0 as an exponent, for every non-zero number a to the 0 is always 1. That means you take any number to the power of 0, and you get 1, unless you've taken 0 to the 0, and you get an undefined answer. Okay? When you have a negative exponent, think negative exponent does not mean negative number. It means really small number. We're going to look for reciprocals. Okay? Usually. So for every non-zero number a, an integer n, a to the negative n equals 1 over a to the n. It equals the reciprocal of a to the n. So that's saying if I have 5 to the negative 3, that will equal 1 over 5 to the third. Okay? What we're going to be working on today is getting algebraic expressions simplified in simplest form. So these things have to be true. And I would highly encourage you to write this part down. Well, all of these. You definitely want them in your notes. An algebraic expression is in simplest form when written with only positive exponents, so you cannot have negative exponents in there at all, and the only common factor of the numerator and the denominator can be 1. Okay, just like I would say, you can't have 4/6, you have to reduce that to 2/3. So we're going to have to make sure that there's no common factor in the numerator and denominator other than 1. So we're going to be looking at quite a few examples. This can get tricky because it's the first time you've seen it, but after you practice, these problems actually become quite quick. All right, so I'm going to ask you to simplify. So the first thing we're looking at is 3 to the negative 2. So what I want you to notice is, okay, I see this negative exponent, I'm thinking reciprocal. 3 to the negative 2, that's not negative 9, don't get fooled. It's the same thing as 1 over 3 squared. We know that 3 squared is 9, so this gives us 1/9. Okay? B, I want you to try that one on your own, and I'm hoping you can get it. Okay, so here we go. It's negative 22.4 to the 0. So the rule is anything to the 0 power, unless the base is 0, equals 1. So lo and behold, even though negative 22.4, it's not that pretty of a number, we take it to the 0th power, we get 1. All right, oh, a little trickier. C means 3a times b to the negative 2. What is important to note here is this is 3 times a times b to the negative 2. It's not all in parentheses. This negative 2, it only has power over the b. When we're looking at this, we want to say, okay, b to the negative 2, remember that's going to be the reciprocal of b squared, so it's going to be 1 over b squared. So what I'm taking here is 3 times a times 1 over b squared, but that's not really that pretty of a form to leave our answer in. So this is a fraction. We can multiply straight across. If you want to, you can put these first numbers over 1. So we've got 3 times a times 1. We have 3a on the top. 1 times b squared, that's b squared on the bottom. And we're done. The reason why we couldn't keep this first as our answer is because there was a negative exponent, and our rule says that when we're simplifying, we may not have a negative exponent in our final answer. So 3a over b squared is how we would simplify that fully. Okay, this time I have 1 over x to the negative 3. I'm going to show you 2 ways to do this, and you can see if either of them makes sense. Okay, so one thing that we know about x to the negative 3 is that so I have this 1 over x to the negative 3. I know that x to the negative 3 is 1 over x cubed. Okay, but this is not a pretty way to write an answer, 1 over x cubed, but that means 1 divided by 1 over x cubed. Okay, and remember when we divide fractions, it's like multiplying by the reciprocal. So we could have 1 times x cubed over 1, which just equals x cubed. X cubed is my answer here. Here's kind of a shortcut that I like to think about doing these problems. When we have 1 over x to the negative 3, a negative exponent should scream to you, reciprocal, reciprocal, reciprocal. So the easiest thing that I like to do is when you take a reciprocal, you flip the numerator and the denominator. 1 is just 1. It doesn't have a negative exponent, so we can leave it how it is. But on the bottom, we have x to the negative 3. So I like to say to myself, that's in the denominator. If I take the reciprocal of it, then it's going to be x to the negative 3 on the top. But my rule says if it's x to the negative 3, that's the same thing as 1 over x cubed. So we're going to take it to a positive exponent when we move it up to the top. So I just usually do some shifting like that. And I want to practice the shifting in this seemingly challenging example. Okay, so here we go, and we'll see how we can do on this. So this is 3a to the negative 2b all over 6c to the negative 4d to the 5th. All right, so I like to think of this instead of writing every single thing out as its own fraction. I like to just think of it all as one big fraction and think about reciprocals and do some moving. So first of all, I look 3. Well, 3, its exponent is 1. Okay, so that's a positive exponent. It does not need to move. We can just leave that as a 3. A to the negative 2. It has a negative exponent, so it should be screaming to you, reciprocal, reciprocal, reciprocal. A to the negative 2 was on top, so I'm going to move a squared on the bottom. Okay, then when I'm looking at the b value here, I've got b. B has a positive exponent, it has just a 1, so I don't need to move it. I can leave it where it is, 3b. Okay, when I'm looking down here at the bottom, at 6, it has a positive exponent of 1, so I can leave 6 where it is on the bottom. C to the negative 4. Oh, it's a negative exponent. I can't leave that in my final answer. Reciprocal, reciprocal, reciprocal. It's on the bottom, so it's going to move up to the top as c to the 4th. And then finally, d to the 5th, positive exponent. Great, it can stay where it is. Okay, the only problem I have with this answer is that it's not reduced fully. If we look here and we have 3 and 6, they have a common factor. You can reduce that to 1/2. You don't even need the 1 on top because you don't need to say 1 times b times c to the 4th. That's the same thing as just b c to the 4th. On the bottom, you can put 2a squared d to the 5th. And that would be my final answer. Okay, I think it's probably worth giving you one like that to see if you can try it on your own and just see if you can get it. So Let's go for it. For x squared y to the negative 2 all over 10 z to the negative 6. Okay, try that one on your own, and then I will check it with you and you can see if you got it right. Okay, so I'm just going to do this first this time, even though I did it last time. I noticed that 4 and 10 have a common factor. I'm going to reduce that to 2/5. And then I'm going to look at each part separately. So I'm going to keep 2, stay on the top, it has a positive exponent. X squared, okay, it has a positive exponent, it can stay on the top. Y to the negative 2, alert, alert, negative exponent's in the wrong place, we'll put that on the bottom. I'm already as a positive exponent, y squared. I leave the 5 on the bottom, it has a positive exponent of 1. Z to the negative 6, alert, 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 it has a negative exponent, reciprocal, it's going to go on the top as z to the 6. This would be my reduced answer. All right. So a few more examples. This time I actually want you to find a final number. So evaluate 4x squared y to the negative 3 if x equals 3 and y equals negative 2. So we can work this one out together. I'm going to rewrite this right away as 4x squared. Those were both nice and fine because they have positive exponents. Y to the negative 3, that has a negative exponent, so reciprocal, it's going to go on the denominator as y to the 3rd. Now I'm going to substitute in my values that I know. So 4 times 3 squared times negative 2 to the 3rd. Okay, now you've got to watch your order of operations or you'll get these wrong every time. So make sure you're squaring 3 before you do something else. 3 squared is 9, so we got 4 times 9, all over negative 2 to the 3rd, which means negative 2 times negative 2 times negative 2, which is negative 8. Okay, I'm going to reduce right now. You can multiply it out first if you want. It's all multiplying, so I'm going to reduce that to 1 and negative 2, because 4 and 8 reduce. And then I'm going to get 9 over negative 2, which is negative 4.5. And that should be my final answer there. Okay, let's look at a word problem, and then you'll try to process this. Okay. So in the lab, the population of a certain bacteria doubles every month. That's very common. The expression 3,000 times 2 to the m models a population of 3,000 bacteria after m months of growth. Evaluate the expression for m equals 0 and m equals negative 2, and then describe what the value of the expression represents in each situation. So it says 3,000 times 2 to the m, and it said evaluate it for m equals 0. So let's try that first. 3,000 times 2 to the 0. All right, awesome. It's a 2 to the 0, so we know that equals 1. And 3,000 times 1 just equals 3,000. Okay, so that means there are 3,000 bacteria and 0 months. So at month 0, so probably when you're starting this project. Okay, so right at the beginning when you're starting the project. Okay, let's look at the next one. 3,000 times 2 to the negative 2. So this time I have 3,000. I can write this either as just like times 1 over 2 squared. That would be okay. So 3,000 times 1/4, or 3,000 divided by 4. I should get 750 bacteria. And this was at negative 2 months. So that probably means 2 months before starting the project. Okay, I don't know if this purple will show up on the black, but we'll try it before starting the project. So some of these word problems, you're going to want to be able to evaluate what they mean in terms of the situation. Okay, so I want you to think about these two things. What does a 0 exponent mean, and what does a negative exponent mean? You should have them really wrapped in your head before you come to class tomorrow. And we'll just get ready to practice a lot until this becomes second nature. All right, see you soon.